In this lesson, we're going to be looking at surds, and specifically we're going to be multiplying and dividing surds together. So we're starting to get into operating with surds. Now, multiplying and dividing surds. We've seen a couple of these rules before. We have seen the first one, which pretty much says that when you square root and square a number, you haven't done anything at all. You haven't changed the number. It stays the same. The second identity we looked at, which helps us in simplifying surds if you go use the rule backwards, is the fact that if you have the square root of one number multiplied by the square root of another number, you can join those two factors together under the one square root sign. You can also work backwards. You can split a number into two factors and then split the surd into two. Today we're going to be introducing the third one, and it's pretty much the same as the multiplying one. It just says that if you want to divide two surds together, you can do that separately, or you can do it under the one square root sign. It doesn't make a difference. Okay, going into some examples. Here we have the square root of 10 times the square root of 6. Now, according to our rule, we can put those together under the one square root sign. So we can have 10 times 6 under the one square root. So that gives us the square root of 60. Now that seems simple enough, but that isn't going to be the most difficult part of these questions we're going to be doing. Once we have performed the operation, we then need to go ahead and simplify the surd. So as always, we need our little assisters to help us in simplifying surds. What are we up to? 6 squared is 36, 7 squared, 8 squared, 9 squared, and 10 squared, and that's about as good as we need. Okay, square root of 60. I need a factor from that list of green numbers that can go into 60. Now what we need, and what is a good idea, it's a good idea to start with the biggest factor, because then you only have to simplify once. If I started with the smallest one and simplified, I might find that I need to simplify the surd again. So let's start ticking them off. 49 definitely doesn't go in, 36 cannot, 25 cannot, 16, can 16 go into 60? No, it cannot. 9, can 9 go into 60? No. What about 4? Can 4 go into 60? Yes. 4 is our factor. We need to write our next line. Now, this seems counterproductive in that we're going from this step of joining them together, and then our remaining few steps, we're going to be pulling them apart again. Now, we need to be able to do this because both this question and this answer are not as simple as they can be. So we need to keep pushing forward. Alright, so the square root of 60 can be the same as the square root of 4 multiplied by 15. Now, we'll split those up. Square root of 4 multiplied by the square root of 15. The square root of 4 is no longer a surd, so we need to write that as a 2 times the square root of 15 for just standard sake, we'll get rid of that multiplication sign and have it as 2 root 15 as our answer. And done. 15 doesn't have any factors over on the side, so we're going to leave it as that. Okay, this next example. Starting to get a little more difficult, a little bigger, but none of the steps change. We still need to multiply the surd by the surd, and in this new example, we now have a coefficient out the front of each surd, and they need to be multiplied together as well. So what we're going to do is we're going to multiply red by red, and we're going to multiply the green by the green. And we can do those in two separate steps. So out the front we will have 5 times the 3, and we can put that in brackets, and dealing with the surds, we can have the square root of 27 times the square root of 6, and we'll close that bracket off. 5 times 3 gives us a 15. Done. Now, the square root of 27 times the square root of 6. We're going to join those together under the one square root sign. So we're going to have 27 times 6. Okay, next one. We have the 15 stays a 15, and the square root, instead of 27 times 6, we're going to have 162. Alright, now we need to begin to simplify this surd. So, let's go down a bit, give myself a little more room. 15 stays the 15, multiplied by, now I need to split this up into two factors, and one of those factors being a perfect square themselves. So have a think about that. what perfect square is a factor of 162? Right, for me, 162, I can see that it is double 81. And 81 is one of our perfect squares. So let's split that up again. 15 times the square root of 81 times the square root of 2. 15 still stays out the front. The square root of 81 is no longer a surd. That is now a whole number, and the square root of 2 remains the square root of 2. Now multiplying 9 by 15, we get 135, multiplied by that square root of 2, and then for standard's sake, we don't need to write that multiplication sign, so it's 135 root 2. Okay, moving on to the division. Now, the steps pretty much stay the same. It's always whole numbers by whole numbers and surds by surds. As you can see in our little rule, we can join our surds together. So in terms of our first one, the square root of 72 divided by the square root of 8, we're going to join it together in one big surd and have it as the square root of 72 divided 8. So our square root sign remains there. 72 divided 8 gives us 9. That is no longer a surd. We can simplify that to be just a 3. Okay, bringing on our next example. The square root of 54 divided by negative root 2. Now, in this example, I find it much easier to do divisions of surds as the first example, when they're written one over the top of another. That way I can match whole numbers to whole numbers and I can match the surds to the surds. So that's what I'm going to do with this one. I'm going to rewrite it as the square root of 54 over negative square root of 2. Alright, working out the answer. Whole numbers by whole numbers. Even though the square root of 54 is missing, you cannot see the whole number out the front, we can always assume that there is a 1 there. Multiplying anything by 1 doesn't change it. So we can assume that there is a 1 on the top and a negative 1 on the bottom. So if we divide 1 by negative 1, we're going to get a negative. It's a negative of 54 divide 2. Alright, the negative remains, the square root sign is still there. Half of 54 is 27. Okay, that's getting there. We're still not quite at this finish line just yet. What we're going to do, we'll go down a little bit. We'll get rid of that top question just so we can see this bottom one. The square root of 27. Now again, referring to that list of factors over on the side, I'm just going to put a few up to remind you. 1, 4, 9, 16, 25. What number over on the side there is a factor of 27? Our negative is going to stay. We're going to have a big square root sign, and I see that it is 9 times 3. Splitting those up, the square root of 9 times the square root of 3, the negative still remaining out the front. The square root of 9 is no longer a surd, so now we have negative 3 multiplied by square root of 3. We don't need that multiplication sign, so we're going to just get rid of it and have negative 3 root 3. Okay, one more example, increasing the difficulty a little bit. It looks hard, but the steps remain the same in its solution. We just need to break it apart a bit. What I'm going to do is I will grab just the top, and we're going to do the top first, and then we can do the division as a second step all on itself. Okay, so rewrite the top. 5 root 2 multiplied by 4 root 12. Now remember, when multiplying surds together, it is the coefficients by coefficients and the surds by the surds. So our next line is going to look like 5 times 4 gives us 20, multiplied by, under the surd, 2 times 12. So that will give us 20 root 24. Now we're going to stop there for the top line. So there is our answer, our new top line, bringing this question down here. Our new top line is our previous answer, and it's 20 root 24, and it's divided by 10 multiplied by the square root of 8. Okay, pulling that on its own. Now remember, division, they run with the same rules as multiplication. It is whole numbers divide whole numbers, and that'll give us 2. And it is the surd divided by the surd. Now I'm going to write this as a middle step, just to make sure that we don't miss anything. So it is 24 divide 8 under that square root sign. So the 2 remains, the square root is still there, 24 divide 8 is 3. I haven't written the multiplication sign, 3 cannot be simplified, so there is the final answer. Okay, I hope you enjoyed this video. That is multiplying and dividing surds. Good luck.